Hi, I'm Brian. This is the sixth video in a series on code generators. And we're going to do a brief one. We're going to cover GUIs, visual designers for code generators, and we're going to talk about metadata extractors. We'll kind of put all those in a similar class, talk about pros and cons. So, pictures worth 1,000 words. I love drawings of architecture. I love drawings of data models. I love drawings of business models, process maps. There's a million drawings, and they're an incredibly useful visual tool. Drawing for you right now. Pictures worth 1,000 words, and at the exact same time, in code generating ecosystems, oftentimes pictures and WYSIWYG interfaces are really painful. So let's talk about why. First, I have a person and a bicycle, right? So we've been talking about persons and their bicycles for a while now. This notation, right? Like, so we did the little crow's foot thing. So a person can have a bunch of bicycles. Maybe that's how you want to represent it. That means you're building in data validation. You can build data validation at your object model. You could build it at the API layer. You could build data validation and foreign key specifications of SQL. All that's phenomenal. It also means the only relationship you can draw between these two is what can be expressed by this particular conventional subset of symbols, which is not the only way to draw a database diagram by any stretch. Let's look over here. I made up my own notation. Person has bike, right? So there's bike. Still looks similar. One person, right, has between 1 and 5 bikes. So bikes are assigned in this data model. Bikes are assigned at birth. You are required. Everyone is compelled to own a bike, but you can never own more than 5. Again, that's really useful metadata. I could totally build that in. And as I have a really complicated model, we're going to add cars and other relationships. So people have bikes, but there are bike mechanics. So people work on bikes. Bikes get sold by salespeople. Like, this model is going to get really complicated, and we're going to want a picture of it. We're going to need to see a picture of it. And what that's going to lend us to is, why can't I draw the picture and do all this? And we have been doing this for years. It's incredibly effective. You just have to understand the constraints that come with it. So a couple of constraints. One, again, you're really hampered by the visual model. And if there's anything that's non-extensible, it tends to be a UI that somebody shipped you. So if you said, hey, I don't like this notation, or hey, I want to model a slightly different way of talking about databases, it might not work. The second one is a little bit hidden, and it is oftentimes visual languages, right? So like, we really did this up with UML, right? We didn't, not database drawings, but if you've ever seen like UML drawings where we've got lots of these tables and class names and then lists of fields and different kinds of containment relationships, like, so really, it was a visual language that was so good at describing object-oriented programming that it didn't work great, because it was really hard to do all of it really well. Nobody ever used all the drawings. The conventions were so specific that they were really confusing. So what you see is like really effective tools that if you draw amazing flawless HTML or UML with their tool, you can get like great stuff, but you end up like training up super experts in this very specific domain language. And it's very rich, right? So like, trying to hand edit some of what comes out of here, even without the third constraint we'll talk about in a minute, that can become very challenging, right? So like, in some environments, this level of visual design constraint is incredibly useful, because you can define lots of cool outputs and super constrain them. You can define very complicated systems. For a lot of like more rapid application development, this tends to be pretty constraining, right? So here we've got like database models, and we're only really talking about, generating database models and maybe some code, but like, the code we generate isn't nearly as cool as what we could maybe do with UML. Both of these then are proving, you're binding the input language largely to the output language. And in some cases, like anchor modeling is a specific one. Anchor modeling like defines a very specific schema out here, and then it bubbles all the way through to the visual modeling language. So it's a really compelling and cool visual modeling language, but it's insanely specific about what it pushes through. And we won't talk about sort of extensibility to templates right now. So we talked about 2 challenges with visual modeling languages, and I still love them. But the third one, The third one also is like annoying. So good code separates data from presentation. Like we've invented 1,000 technologies to separate data from presentation. This is data and its presentation. And one of the things that people always want to do in a graphical modeling tool is if you let them design things in this tool, the next thing that you want to do is control layout. Layout algorithms of graphs. You can go get a PhD. There's like entire subsection of computer science and theory about doing effective and efficient automatic layout of graphs, giving all kinds of scenarios and constraints. And given all of that advancement, you will invariably want to potentially manipulate that model. And the moment you allow it in your graphical modeling tool, you now have to store the layout information so that when they open it again, it looks the same, right? Because suddenly the layout information is part of what they're conveying and sharing between users. So we don't operate in a void. All these things are kind of going into source control somewhere. All these things are designed to be sharing a higher level language such that we can, be way more effective over here, right? We're going to code generate to superheroes. But that means that the layout, where are we going to store that? And like what you don't want to see is here's my data model. And then also let me put XY coordinates in here, right? Because now my data model is like completely polluted with the visual information that some particular tool likes to show. The challenge with it is where else are you going to put it? Everywhere else, if your tool is file system based, now you're maybe managing two separate files, right? So a bunch of visual modeling tools actually do this. They leave your object model alone and they create a new metadata file where they track all the layout information. And now, like, I'm dependent on this tool to synchronize this file. There presents a ton of annoyances in doing that well on the file system. If you're doing it cloud, you've got some like web-based editing tool, same challenges, right? Where are they storing the layout information? Is that in a database that is separate from the code that's like going into my GitHub repo? Because now I can't actually produce the documents and the diagrams that I was interested in because I took the time to make the layout. If that's not code, I'm bound to some tool, right? And so again, a bit of a challenge. Okay, the last one, right? Like I hate to pick on visual tools, but I spent like a lot of time being deeply fascinated with them, and then back to code again, and sort of view only diagrams from code is the best I'm hopeful for today. And here's why. Not only are these usually tied like really directly through to the output, usually or oftentimes like these things are built by people who are really good at building one of these things. So I'm really good at building this kind of data warehouse. I'm really good at building this kind of model, but it's complicated and algorithmically can be produced from a drawing, right? So like I'm going to go build the most effective tool to go straight line from point A to point B. What I'm often not going to be thinking about nearly as much then is, does this resolve to some like input model that's even like real data somebody can enter? Or is the UX the only way to do it? Like, is it truly sitting on top of a human editable set of models? Or does it just go straight through, right? And you take the input and it's visual and it's data and it's layout and it's everything. And like all this is just blurry. And then you get one kind of output. And if you said, hey, like, let me use your visual model, but add some new templates to go add some of this other stuff and do this other multiplicity, like the whole thing falls apart, right? Because it turns out a lot of them are not built as general purpose tools. They're built as visual tools for one specific target, right? And so you skip some of the rigor maybe on general purpose code generation and templating. Now, one other subclass of tool in here is metadata extractors, right? I should put extractors on here. This one oftentimes, they sell this one a lot of times as a passive code generator tool. So like the standard use case is, hey, there's a database sitting out there somewhere. And what I don't have is a bunch of structured metadata about it. Like maybe I've got a bunch of create scripts over years or over multiple versions or whatever, but I want to go and hit it. And I want to produce like nice documentation, and I want to produce some other code, maybe. Like there's all kinds of good reasons why I want to point at a database and reverse engineer. So there's an entire industry of tools that are essentially code generators. And all they do is learn how to extract all the metadata via a bunch of API calls from a bunch of different database engines. And then you build a model, and then you run it through some templates, and then you generate, a bunch of outputs. These tools tend to fall into the same kind of problems that visual tools do, in that they're so caught up in the output, and the output, the line from here to here is so clean that the model ends up being highly specific to this, right? Like, which it should be. If you want no information loss and complete fidelity, then the model that you extract from here to produce scripts that can reproduce it, it has to be equal fidelity, right? So it's a code generator, and it may generate you some like other cool artifacts, but ultimately it's 100% fidelity to this physical structure. And it doesn't really buy you like the level of abstraction and reuse that you get out of a model-based code generator. So metadata-based extraction code generator is really cool. There's an SDLC play here for some of these, where they play for, hey, we'll let you take snapshots of the model, and then we'll do delta detection. So you can run this tool against your database every day. We're going to produce a model. We're going to compare it to the previous model. And then we're going to run the delta through a code generator and spit out a report. It's a useful and interesting use case, I guess. I feel like if your database is changing, you don't know about it, we had a completely different discussion, and maybe you don't need a code generator. So that covers WYSIWYG, right? WYSIWYG with the sad face, because I saw this presentation years ago. The guy said, WYSIWYG interfaces are awesome. What you see is what you get. And the challenge is what you see is all you get. And so when I say things like, oh, I want to add a new property to person, right? I want to add a new ability. I want to add some new templates. I want to continue to get exponential value out of my investment in data modeling. I need to make really particular decisions about where I'm doing which kind of code generation and data modeling. And these tools, like, they can be really attractive in the beginning, and then sort of in SDLC and in change and in extensibility and sort of model flexibility, that you end up really paying a big cost and going to find another tool. And by the way, it's fine if you have 2 or 3 code generating tools. What you should have is a coherent structure and understanding of how they work together. Different conversation. We're going to pause, and we're going to cover interface usage and SDLC CI/CD next.